Modeling is fundamentally a scientific process, which is different from traditional software engineering in that it requires experimentation to explore and find solutions to problems. Experimentation comes in many forms, from hypothesis testing to model and feature selection to hyperparameter optimization. To accelerate and amplify impact, modelers need intelligent experimentation tools. To get modeling right, you need to get experimentation right. But experimentation is tedious, messy, and full of dead ends. It's easy for modelers to get mired in the details of experimentation and overwhelmed with the decisions and tasks they need to make in the process. With the SigOpt Intelligent Experimentation Platform, there is a better way. SigOpt makes it easy to track runs, manage hyperparameter optimization, and scale experimentation with just a few lines of code. Modelers use SigOpt to design experiments to ask the right questions, explore their modeling problem space, and optimize their models. Experimentation provides insight into cause and effect by demonstrating what outcome occurs when a particular component is manipulated. Intelligent experimentation with SigOpt goes beyond the typical capabilities of experimentation tools by making recommendations based on design decisions, how to explore modeling problems so you can find the optimal solutions. SigOpt is useful for any use case or industry. This is why hundreds of companies rely on SigOpt to standardize and enhance their experimentation. And you can use it free. In fact, you can sign up today. To see the platform's benefits in action, let's explore a classic modeling problem. In fact, it's a problem you can execute yourself from our examples. Watch how easy it is to design, explore, and optimize your experimentation with SigOpt. In this example modeling problem, our goal is to optimize XGBoost for higher accuracy on a breast cancer dataset with a binary classification task on the labels of malignant or benign. You can use SigOpt in your preferred IDE for any model or modeling problem. In this case, we're using an IPython notebook. After you have pip installed SigOpt, you simply have to import the library, add a few lines of SigOpt code to your modeling code, and start tracking runs. Now, SigOpt will log these parameter values with the run object. This makes it easy to transition between single training runs or at-scale hyperparameter optimization experiments while using SigOpt throughout the process. Exploring results across the runs executed when tuning a model is important for understanding a model's behavior. Manually vary the tunable inputs or hyperparameters to see how they impact the desired outputs or metrics. All runs are tracked to facilitate efficient analysis on how parameters impacted your metrics and gain insight into designing a subsequent training run or experiment. Here we see a web app visualization at the project layer, where 5 executed training runs are grouped. In addition to visualizations, modeling flows often require a clean view of raw data to generate the right questions about what to do next. The Runs tab of the project page in this image shows the high-dimensional run data. This particular collection of runs shows that the tuning set accuracy is always above 90% as an aggressive threshold for a constraint metric when designing the optimization experiment. Now that there is a benchmark, it is simple to design an experiment to evaluate model performance across the metrics we care about. In this case, we store a variety of metrics we want to monitor through training. We set a few metrics as constraints within the experiment, and we optimize recall, our objective metric. SigOpt makes it simple to store metrics, apply metrics as constraints, and optimize metrics, so you are always using metrics exactly how you want to in your modeling problem. Next, we define the hyperparameters. We will configure these hyperparameters to maximize recall. Note how little you need to modify your own model code. A powerful feature of SigOpt is to run this same code on many virtual machines in parallel to perform at-scale hyperparameter optimization with no changes. The experiment landing page shows the results of hyperparameter tuning. There are 2 optimization metrics to maximize in this experiment: You can see the good results are up and to the right in our 2D metric space. We observe 3 points on the Pareto frontier. Explore the experiment analysis page for immediate access to the run data populating this experiment in a variety of informative visualizations. Here you see the right side plot showing the runs that did not meet the tuning set accuracy threshold are grayed out, meaning those points are not valid configurations regardless of how well they perform on optimized metrics. Experimentation is an iterative process. After optimization, you can go back and design new experiments, such as new model types, or explore to better understand the model and metrics, or re-optimize, like when doing multi-metric optimization. The platform also offers an easy-to-use API for cutting-edge optimization. Altogether, you can streamline, accelerate, and amplify the impact of your experimentation with SigOpt. SigOpt is helping modelers in every industry to design, explore, and optimize better models faster and easier. Harness the power of SigOpt Intelligent Experimentation Platform free. Check out these links to amplify your modeling workflows today.